Good afternoon, ladies and gentlemen. I, Lieutenant Colonel Aditya Bhosle, am coming from Military College of Electronics and Mechanical Engineering, which is located in Secunderabad. We have been taking numerous efforts in order to implement and adopt the niche technology of artificial intelligence, keeping in view the plethora of varied deployment of Indian Army with variety of equipment deployed at different places. Now, what I'm going to speak is about the land domain and specifically about the uncrewed and unmanned systems. This is very commonly known as the unmanned ground vehicles or the UGVs. When we speak about UGVs, these UGVs have not come to existence today or a few years back. They are there in existence more than 100 years ago. As has already been brought out in the presentation given previously, these UGVs have been existing since ages. However, the difference which has come into place is the artificial intelligence which we have built up embedded into these UGVs to augment the existing capability of human beings. When I mean that, I'm trying to make these UGVs autonomous, I mean to augment the human capacity in terms of carrying out operations, carrying out groundwork, which is physically giving a limiting factor in terms of dangerous difficulties and various limitations existing on ground. The level of autonomy is required to be discussed, as the level of autonomy can be a remote controlled, a remote guided, or a total autonomous system which is operating on its own. I shall be covering my presentation in a very short span of time, in which I'll try to address all the military requirements and the technological challenges which we face in addressing all these requirements. Next slide, please. As I said, the technology has been existing for over 100 years. In 1904, there was a first small step which was taken place wherein a UGV was tried to be developed and controlled remotely. With time, the World War gave a necessity for an invention, and thus there was a development on this aspect. Subsequently, as technology improved and the compute power improved at the end device and at the controlling device, the level of UGVs have kept on improving with time, and the autonomousity in that particular equipment has increased with time. Next slide, please. When we talk about the design parameters demands a lot of issues. Firstly, when I talk about a particular platform, aim of a UGV comes into play. The place where this UGV is getting deployed, the terrain which it is going to get deployed, the range which is envisaged, the time of operation which is envisaged, the size of the UGV which is envisaged. All these parameters together give us a domain or a platform which we have to define for a particular UGV. With the limitations of all the aspects of this aim, I have to define my size, the power source, and all number of factors. So here is where the technology is challenging. Coming over to the aim, coming back to the aim again, when I mean to say that I have a particular aim, I need to embed this particular UGV with number of sensors with regards to monitoring the space, navigating from place A to place B, collecting data, processing the data, and sending it back. So when we speak about data availability at the UGV level is humongous. However, the processing capability to embed into that UGV is a matter of concern. A level of processing exists at the UGV end, and also data is getting streamed back to the controller, where the controller is trying to process the data and predict the future course of action of that particular UGV. Thus, the autonomicity built into that UGV is a combination of various technologies to make an effective system on ground. With this, we have a lot of applications in civil and military domain. Next slide, please. I'll just, as the slide flashes, in civil domain, we have various commercial applications and government monitoring-based applications. But talking specifically about the military domain, next slide, please. I will give an example of a soldier. When a soldier is moving into an operation, what is required for him is to understand and have a situational awareness about the battlefield which is about to enter. For that, he requires some initial information of the adversary, which is obtained by means of various surveillance and recce methodologies, or usage of these UGVs as escorts or scouts, which is leading the battlefield. This information helps him to gain some pre-operational information, which helps him take a sound, informed decision. When he is in ops, he is required to address various aspects like crossing of a minefield. While negotiating a minefield, a soldier is trained to do so. However, his physical limitations and the ingenuity which has been put by the adversary while laying that minefield can be only addressed with the use of the latest technology. Various sensors, as we mentioned, can detect and map the minefields and also help us to neutralize the minefields or cross the minefields in a particular way. Similarly is the case with the ID detection in especially the CI and CT environment. Moving on to the operational support part, that is the logistics. The logistics support, the medical and casualty evacuation, and such like parameters are of key when an operation is taking place. These factors can excellently be augmented with the existing resources by using these unmanned autonomous vehicles. Next slide, please. As I show on the screen, there are few of the UGVs which are existing, and maybe few of the stakeholders would already be sitting with us, like DRDO and CARE are sitting with us. The first one on the left corner is the robotic buddy, which has been developed by the Simulator Development Division at MCME. And as you see visually, it is very easy to appreciate. Every UGV is specific for a particular task. It is addressing the requirements of different terrain by means of tracked or wheeled or legged platforms. Its size and intention of operations are different, and thus all the UGVs are trying to address different areas of the warfare. Next slide, please. If we talk about the operational requirements, as of now, two conflicts which are going on between Ukraine, Russia, and Israel and Gaza, we see a lot of usage of UGVs in this place. The unmanned vehicles by Russia are being used for transportation of logistics and medical casualty evacuation, and as is available in open domain. With this, I come on to the overall advantages of the system, wherein UGVs and unmanned vehicles are the force multipliers of the day. They can have the capability to expand the battlefield with reducing risk and casualties to the own soldiers. Embedding AI is going to give us a huge leap into technology and effectiveness in the operations. The scalability and versatility is an inherent characteristic of each and every UGV. As we talk about technological superiority, the processing at the end of the UGV and at the controller's end is a technological challenge and is being addressed as per the technology processes. The multi-domain implementation of this particular technology is widely tested and proved to be good in the operational scenario. Next slide, please. Next. With the limitations of this technology, as we see, whenever a software or a hardware is designed and developed, it is done by a team of experts. They do cater for all the possible parameters of that software. However, this makes some things unpredictable which have not been catered. There therefore exists a necessity for overall control in the entire process of autonomous operation. A human in or on the loop is a mandatory requirement which is considered. There may be errors which can be there in the system, which can cumulatively cause multiple issues and also lead to collateral damages, which include the accidental damages in civil areas. These are heavily using the software technologies of artificial intelligence and are prone to hacking and cyber threats, as has already been discussed in previous presentations. Overall, if you see an autonomous nature of this UGVs, there is a challenge with regards to the accountability of accountability of the actions of that UGV taken on ground. Next slide, please. As way ahead, as thoughts which we can take forward from this talk is that new technology has forced changes into the operational domain. The operational tactics are getting changed, the strategies are getting changed. However, how better we adopt is the way we are going to succeed. The UGVs, being the game changer, have their inherent tactical advantages and is being proved through various wars and the conflicts which are going on right now. The matter of ethics in AI is a matter of concern, which has already been deliberated in detail and is being addressed to various policies in the various national policies and also the policies which are being followed by the Indian Army. And at the end, I would like to complete here at the point that the human in or on the loop is a mandatory thing in order to control the overall autonomous nature of these UGVs. I'm done. Thank you.